Okay, so many thanks for the invitation, and also for the great presentations from John and Maria. As you told, we are part of a group of projects dealing with these types of systems for building facade systems. A little bit similar, like in the plural project that Maria presented before. My project, POWERSKIN Project, is also dealing with prefabricated modules. In our case, we don't call it kits, we call it modules. And we are working also in transparent and opaque models. But I will get a little bit further later on in the presentation. It will be a very brief presentation just to give you a glimpse of what we are doing and what is the framework of our project. So basically, well, the project calls highly advanced modular integration of insulation, energizing and storage systems for non-residential buildings. We were funded on the 2019 call for energy efficiency buildings. We started some years ago. It's a 4-year project. Actually, we just asked for a little bit more time, 6 months more time, due to the delays imposed by the pandemic crisis. But we are on really nice track on the project developments. So the concept behind POWERSKIN Plus try to releases the potential of curtain wall facades for really highly efficient energy valorization in buildings. And we are trying to develop this modular integrated approach consisting on different and several innovations that can be merged into the same system and add this added value intent to suppress the available alternatives currently available in the market. So we're trying to be a truly integrative smart curtain wall facade solutions that tries to comprise super insulation along with solar energy harvesting solutions and link those also with active and passive energy storage features. This is a sketch that I normally present when I want to let people know what we are doing in POWERSKIN. So basically, we are working with facade systems, basically curtain wall facade systems, and we are developing these different transparent and opaque modules and mixing it with what we call it add-ons if we want to have a superior efficiency or a superior energy saving solution. So we want to be an all combined modular energy measurement package towards obviously energy efficiency, but we are also trying to tackle those issues with sustainable eco design standards, as I told you before, especially in addressing non-residential solutions, but actually this can be tailor-made for other types of buildings, including residential ones. So the main key objectives of the project. So we are trying to generate these hybrid enabled systems with multifunctional add-on features for curtain wall solutions. And one of the biggest objectives of the project is to demonstrate this holistic facade solution in an operational environment, which is actually what we are starting to doing right now. Trying to make the early paths for future exploitation of the project outcomes. So we are trying to provide the retrofit market with this highly adaptive multi-case energy efficiency and management systems. But also we are looking quite sharply to the new buildings one as well. So basically, we want to set POWERSKIN from lab to operational environment. So in the end of the project, we will end most of our developments in TRL7, although there are already some modules and some elements that are already in the market. So one's very close to the market and others already in the market. The project methodology. So this is a very, very typical slide of the different work packages of the project. So basically, we are trying to develop different CATs, key enabling technologies, all mixed in a piloting program. So we are dealing with super insulation elements. We are working with, for the transparent part elements, we are working with IGUs, and for the opaque systems, we are working with vacuum insulated panels as the main insulation element of our models. So we are also combining this with nano-enabled coatings, with active and passive phase change material, heat storage elements, and microfluidic thermal storage materials for the transparent units. And we are also combining our systems with solar energy harvesting components based on perovskite solar cells, both also for the semi-transparent and opaque modules. And in the end, trying to get the maximum performance out of these energy harvesting solutions with the help of electrical building management systems supported by second life lithium-ion batteries from electrical vehicles, recycled batteries coming already from electrical vehicles. So as Maria told about PLURAL, we also have a work package dedicated for system production and manufacturing, and how to integrate this different opaques and transparent elements in a framing facade system. We worked in different types of work package for the transparent and for the opaque, and then we integrate all of these elements and add-ons in production, and after simulation, characterization, and validation, and the environmental and economic analysis, we intend to do what we are doing right now, which is starting our pilot demonstration of the solutions that we are tackling. So just to provide you a notion on what are our transparent models and add-ons. So basically, POWERSKIN starts with the standard option. The most economic option will be the standard one. So it's a typical triple glaze insulation glass unit, IGU, that we developed to be designed to be worked in a typical modular framing system, either a metal or a composite framing system, which can be a stick or a unitized plug-and-play installation system. Then this is the standard, so the minimum requires for any type of energy efficiency. So in the premium options, we start including layers of different solutions that can enhance the performance of the facade of the building. When we call this the premium option, so basically, obviously, we use functional nano coatings on these triple glazed insulation glass units for self-cleaning, anti-reflective, also for photocatalytic properties, and wavelength control for PV power generation, which I will talk a little bit later on. Then we also have an add-on that was developed by some partners of POWERSKIN, driven from a previous European project, which are these capillary glass sheets for active thermal heat storage and diversion using microfluidic active thermal storage material. So basically, this is a fluid that is pumped inside these thin channels in the glass pane in the triple glaze IGU that removes heat and recovers this heat, for instance, to be used in the heat recovering system of the building. Then we work with also facade building integration photovoltaic cells. We are not using silicon ones. We are working with the perovskite PVs with the help of a partner of POWERSKIN, which is Sol Technologies. And we are developing both semi-transparent and opaque PV cells of perovskite to be integrated in our modules. And As I told you before, we link this facade building integrated photovoltaics and the energy harvesting that we can generate from those. We can store it in our lithium-ion battery electric storage system using the recycled batteries coming from electrical vehicles. This battery system is being developing by a University of Warsaw. Some examples of our modules being tested and being prototyped and tested in lab. Just for getting some notion. Basically, we are running already some tests on some test cells in Italy, in Polytechnic Torino, and we are starting to getting these tests to the real buildings on to making installation in real buildings starting this autumn. On the top pictures, you can see some examples of the perovskite semi-transparent cells. So you can see that actually you can see through them. And this is quite an achievement that Sol Technologies is getting for the project. Regarding the OPAC modules and add-ons, so we start with the standard option is basically some OPAC panels with skins, and a front skin and a back skin that can be a glass driven from glass, composite, or metal, and the core body of these OPAC modules is a super insulation model made by vacuum insulated panels. Actually, this is work of Instituto Pedro Nunes, from where I came from, where I am. And this is part of our developments. So basically, we are trying to develop new vacuum insulated panels with enhanced core systems and alternative core systems. We are getting 2 patents out of our core solutions developed inside the project. And we can use this OPAC modules again in the same modular framing system as stick one or unitized plug-and-play installation. Then we've got the same premium option as we have for the transparent solutions and transparent elements. Again, functional nano coatings for UV weatherability, fire resistance of the skin panels, for instance. We are working also with latent heat storage systems using phase change materials, not only for this heat storage solution, but also to enhance the performance of the add-on coming from the perovskite solar cells, to increase the service life of this PV solutions, and forbidding those to get too much heat during the summertime, and also link the same PV cells to this electric storage system as in the transparent elements and modules. These are some of our developments for the OPAC modules, where you can see the VIP solutions that IPN developed. We created a pilot production testing here at the institute for the project. You can see the interior of the premium option, having the PCMs included in the model, that we also work with some heating foils to activate the PCM work. You can see also the OPAC flexible perovskite PV prototypes in the middle figures, and some of the batteries, the lithium-ion recycled batteries that University of Warsaw is developing and getting for the project. We have 3 demos, 3 prototype buildings, real buildings, sorry, to prototype and demonstrate our solutions. One will be here at IPN campus, and the other two will be in Germany and the Czech Republic. The Germany building is the building of one of our partners, Flash Glass Company, and the Czech Republic building is in the campus of the Prague Polytechnical, the Polytechnical of Prague, CVUT, representing different types of non-residential buildings and in different types of climates. This is the pilot installation that we are going to get in IPN campus. We are starting within 15 days. We are starting to make this installation for POWERSKIN in one of our facade buildings. The timeline for our results, basically, so right now we are making this installation to get the full year demonstration in operational environment for our systems. And next year we want to have the full lab scale experimental validation completed, and all the document database and future market entering guidelines to prove the efficiency of our solutions, including environmental and economical analysis. Some of the key barriers and challenges of the project and of the solutions, basically, the cost of these high performance solutions is still a very big barrier for market entrance, and obviously in these challenging times it's even higher. It's bigger, this barrier. And also, as John showed us in the first presentation, the slow pace of the EU retrofit action. Actually, I'm very skeptical that we will be able to get to the targets that the European Commission pointed for this renovation of the building stock. It's still very slow, the pace that we are making this retrofit action. Regarding the technology challenges, obviously it's very difficult to develop these multi-price, efficient plug-and-play modular solutions with an easier market acceptance. There's really the need to address this holistic full cycle approach on the product, but we are experiencing very difficulties when we are working with retrofit solutions, especially because most of these modular systems and prefabricated systems, it's very hard to adapt those in a true prefabricated concept. It's very difficult to adapt those to the real world when we are talking about retrofit actions. It's very because prefabricated, it's all about standard dimensions, standardized dimensions for manufacturing. When you start to adapt and try to adapt the standardization standardized elements for and adapt this to real buildings that doesn't cover for instance, the dimensions of these elements, you start getting to have a lot of problems, and actually it starts to be less productive, the manufacturing of prefabricated systems. So we need to be very careful when we are talking about retrofit with standardized and prefabricated elements, because all the architectural barriers that are imposed for those, it's very different to work with real new buildings. Obviously, this is got everything to do with regulatory and other challenges that we are facing. So we need to design a portfolio of standardized solutions capable of fulfilling different regulatory requirements along the different types of countries. And finally, there are still some bottlenecks preventing further industrial uptake of some materials, for instance, some nanomaterials, that we are also experiencing as a barrier. So basically, that's all from my side. You can follow us in our social media network profiles. Obviously, you can contact me anytime if you want any further project information. You have my contacts, and many thanks for your attention.